Next one up is Oliver Gugger. He's one of the lightning lizards wizards. from Lightning Labs, and so put your hands together for Ollie.
Thank you, Jeff. Those of you who were here 2 years ago might think this is the same talk as was given back then by Antoine, but this is a lot of stuff has happened since then. It's been 2 years, so this is update what's been going on discussions around Taproot on Lightning. I'm going to talk about the current state, the current definition of the next steps, and then how we might get there. So current state, we're all here because, a lot of these talks are about Taproot because it's been activated. Okay, very obvious. But I guess one of the important next steps is, you're going to hear me talk about Music 2 a lot because it's one of the dependencies for a lot of stuff that we want to do in Lightning. So the Music 2 spec has recently been merged into the CKP fork, which is a fork from Blockstream where the cryptographers work on. And it being merged there means at least the cryptographers think it's final. There's a reference implementation, so that's first important step. I guess the next step is for it to be actually merged to the upstream repository, the one that BitcoinD uses. And from what I heard is that most of the other implementations, Eclair, LDK, and C-Lightning use the SecP library, so there's kind of this dependency. What we've done, because LND is pure Go, including all the elliptic curve stuff, is we've started adding code there, mainly Lalo, aka roast beef. So we have a version 2 of our elliptic curve library that's merged, that brings some nice free speedups by using proper mod and scalar values and some of other field calculation optimization. So that will speed up general operations in LND. The Taproot validation logic has been added to BTCD, which is a pure implementation, Go implementation of the whole Taproot TapScript validation logic, which we are going to pull into LND as a library. And that's very close to being merged, so hopefully very soon. And then our next version of LND, which is currently 0.15 or will be 0.15, will have basic wallet, just send and receive support. And on the RPC side, first preliminary TapScript spending and signing support. And I think the PR is now also up, so the Golang implementation of Music 2 is also on the way. So kind of have kind of a bit of a head start there because we can start integrating on top of that and don't need to wait for the upstream 2 of the SecP library. Okay, what are the next steps? I'm going to deep dive into those. They've been kind of assembled in Zurich at the last Lightning meetup. And it's a somewhat ordered list, so there's a basic agreement that it should be more or less in these steps. There are dependencies in between them. But there's still a lot of discussion going on. So some of those steps have an actual PR in the spec. Others were just announcement on the mailing list. So one of the first kind of low-hanging fruit is to just do Music 2 and Gossip. Currently, to announce a channel, we send out a message with 4 signatures in it, 2 for each of the node pub keys and 2 for each of the Bitcoin on-chain keys that have been used to create a channel. And those could just be simply aggregated into one music Schnorr signature. So that would save some space on the chain. Of course, need to figure out how to do proper versioning of this so that we are backward compatible with nodes that don't understand this. There was also a proposal, if we touch this, why not go with a complete revamp of Gossip, Gossip version 2 protocol, switch over more messages to use TLV natively, and have some basic other improvements in there. And also one cool idea in there in the Gossip v2 proposal is to decouple the proof for a UTXO from the proof from a channel. So you don't actually have to announce what channels, UTXOs you own. It's you only basically prove you own one UTXO, which is the denial of service limiting factor, but you don't need to deliver proof for each individual channel. So there are some interesting ideas in there. Also, if we do V2, then there will probably be some optional fields for the future to maybe include zero knowledge proof and stuff like that. Then kind of the obvious next step is, I guess this is one of the things that's mostly talked about by the community, to hide the channel funding outputs by using music 2 of 2. So all the chain sees is a normal Taproot key, and if it's closed cooperatively, you don't see any script or anything, so it could look like any other transaction. To get there, this is a slide from Jonas Nick. We need to exchange these 2 nonces. They can be added to the current messages that the peers send to establish the channel, so that shouldn't be too big of a change. Just add some new fields with these nonces, so they can be sent back and forth. I guess the main difficulty here is, and I think that touches on what Stefan said this morning, that we need to be careful to never store these nonces, never serialize them anywhere, so that they're never reused, that no private key leakage can occur. I mean, it could even be that one party could derive these nonces deterministically once it has got the message and the nonces from the other peer, so that at least one side doesn't have to do randomness and think about all this stuff. But that's all still being discussed how to actually do that. What does it mean? Do we now need to, if we go down that route, do we need to close all old channels and open new ones? Maybe not, hopefully not, probably not. I'm going to talk about the channel upgrade in a later slide as well. Next step would be a kind of naive translation of the current witness scripts that we use. This is the example for just basic commitment commitment output. This is the toLocal output. And we're basically just one-to-one transform them into tab scripts. And we just remove the kind of branches, the ifs, and put them into separate leaves. We would replace any multi-signature stuff with the new op-sig-hash, sig-add opcode. Everything would be like any check sig would now be Schnorr signature, but we wouldn't necessarily go define any key spend path. why would we even do that if there is an optimization? Well, to go through the key spend path, that would probably be a music 2. So we need to have more nonces everywhere. We need to think about in what messages do we add nonces to actually have them for everywhere where we need this key. So it might just be a bigger lift. So it could be an option to just go this first step and get some wins. So we get some privacy wins here by not needing to reveal the whole script. And also we could just learn how to handle all of this. And also on the implementation side, it might be easier because we could reuse some of the code to detect the witness stack, which path was actually taken. Might just be an easier step than to do the whole lift. But if we don't use the key spend route, then we need to make sure that this actually can't be spent. So we'll probably use some kind of nums or nothing up my sleeve public key where you can prove that no one has the private key for it. We might not do that step. It was just a proposal. Maybe you want to do everything in one go, but yeah, that's one version. Then the next step would be to actually look into which keys could we lift up to the internal key, the key spend path. And yeah, then we would need to think about where do we add these nonces and what keys do we actually use here. We could use music 2 for some of the revocation stuff. I guess we could theoretically also reuse the tweaked private key that we currently have and just put it up here. I didn't find a reason for not doing that, but maybe it's just nicer to have music 2 everywhere. And then, so the revocation, this would apply to channel commitments, but and HDLCs as well. So we would get some privacy and size savings there too. Then the next step would be, I think this is the biggest step of them all, and it's probably also one of those that most people talk about when thinking about Taproot on Lightning. So PTLCs means instead of using a hash time lock contract, which has one single secret that is hashed, so one hash that is seen along the whole route, would be replaced by still a single secret, but that single secret would be applied to all of the keys on the route, and every hop would only see a key that belongs to them and couldn't correlate the payment on the path anymore. So if the same entity owns multiple nodes along the same route, it couldn't say this is the same payment, while today they could do that. So the point time lock contracts are a way to achieve payment decorrelation. The downside is that to do it, you have to have all hops on the route need to support it. You can't mix the two of them. So we probably need to be backward compatible for a while. And we need to make sure that once we roll out PTLCs, we can get as many channels as possible upgraded quickly. And luckily, there's a proposal from Lalo, aka Roast Beef, how to do the dynamic commitment upgrade so that nodes could agree to upgrade to a new channel format without needing to close and reopen the channel. Of course, this only applies to like the commitment transactions that are off-chain. You cannot really replace the funding 2 of 2 pay-to-witness script hash that we already have on-chain. But there's been a proposal by Seaman how we could do kind of an upgrade transaction for that as well, to move that over to a Taproot output, but still keep that transaction off-chain. And that would basically allow us to get rid of some of the state, of the old state. It could go on-chain, but doesn't have to. So there's a lot of things that can be done, the upgrade. By the way, Bastien, aka T-Bast, has this very nice write-up where I took these screenshots from. Because, again, more nonces need to be exchanged, and also with the PTLCs, the way that the secret is revealed when they need to go on chain because something went wrong, to pull the payment along the route, because it's not a single secret anymore, a single hash secret that you can observe on chain and then use to pull your end. Some trickery needs to be used, basically adapter signatures, which is a signature that itself reveals some information to someone who knows what to do with it, and that the adapter signatures work in PTLCs. The PTLCs have to be moved into 2 stages, and all of that just requires that there's more data exchanged between the peers. So that would mean we get half a round trip more for the whole the commitment update dance. Then we go into the far or further future. At some point, we hopefully get L2. Yeah, okay, still here. Because L2 has these sequential update transactions, it looks a bit different. The commitments look a bit different. It's actually in several layers. So there's the funding transaction, then an update transactions, multiple of them, and if there's a HTLC or PTLC ongoing, then there could be also a claim and a settlement transaction. And some of those could be folded in or simplified just by using music2 and Schnorr signatures. So with Taproot and Schnorr, we get some optimizations for ideas that have been around for a very long time and can now just benefit from, in general, from us rolling out Taproot. Then is, of course, the question, how do we get there? It's always a possibility, big bang, like all implementations, agree, okay, we're going to work on this for 2 years, 4 years, I don't know, and then just, okay, everyone ready, yes, now we upgrade. I mean, just from an efficiency standpoint, it would probably be the easiest because you touch all the code bases only once. But also, of course, it's the highest risk. So I think it's generally agreed upon that it might not be a good idea, or we want to go with a more incremental approach. But if just we go through all these steps incrementally, then it means we probably touch the same code base 2 or 3 or 4 times, which, yeah, is also not maybe the most efficient one. But it gives us a chance to maybe learn something on the way that we could then improve upon in later steps. So, yeah, still very much up for discussion. Yeah, and also if there are 4 steps, knowing what step or what version the other peer is currently on. So we need to add version flags everywhere, feature bits, whatever. Yeah, and keeping track of the feature bits, knowing which ones are additive, which ones are mutually exclusive, is also kind of a big hassle and has led to some problems before. So yeah, it's still will be a lot of work in either way, I assume. All right, this last slide is not directly related to the previous ones. It's just while working on some of the Taproot stuff, Lalo, basically noticed that there's this one little trick you could use with a Taproot output that basically the Taproot you commit to if you never want to go down a key spend path, you don't really need to have a script in there, right? So you could just commit to anything, which is basically what a lot of protocols use, like just op return and then a hash. So you could just roll that into a Taproot output. And we are currently working on a proposal, so hopefully something will be out soon how we could use that. All right, I'm gonna answer some questions, and if there aren't that many, I hope to give you a few minutes back from your break. So thank you very much.
Thank you. Can you go back to the slide where you said we may not want to use the internal pub key? Because
yes.
Actually, we always do want to use it because there's no downside. We always want this to be a musig of the revocation key and the remote key, because then it's a musig between you and you. So you don't have to store any nonces, because it's always the remote that uses the revocation path. So he has both keys. It is a musig, but it's only one guy doing both sides. So I think there's always an upside to using it.
Okay, cool. Didn't know that. Thank you.
Anyone else?
Thank you, Ollie.